Welcome to Key Tech. Please describe this channel if you're interested in today's video. A key technology that Western countries have struggled to master for years has now been successfully overcome by China. Recently, authoritative institutions such as the Chinese Academy of Sciences officially announced that China has successfully built the world's first and currently only operational thorium-based molten salt reactor in Gansu province, and has successfully completed core verification work. This fourth-generation nuclear power experimental device, using thorium as fuel and molten salt for cooling, not only possesses highly efficient power generation capabilities but also has broad application prospects in the future, potentially extending to industries with high thermal energy demands, such as hydrogen production. Based on scientific evidence, experts from the Chinese Academy of Sciences conservatively estimate that China's proven thorium resources of 286,000 tons alone are sufficient to meet the nation's energy needs for over 1,000 years. Expanding the scope globally, thorium resources could support global energy consumption for over 10,000 years. Industry experts believe that this technological breakthrough could potentially change the current traditional energy landscape dominated by oil. 1. More powerful than existing energy sources. A small handful can power a household for 800 years. Previously, in order to obtain electricity, China recklessly cut down trees and mined minerals, leading to the depletion of natural resources and the imbalance of the ecosystem. Today, nuclear power has become a highly advantageous alternative. However, the resulting nuclear pollution problem has become a new challenge. Thorium-based molten salt reactors differ significantly from coal and oil/gas burning power generation. Based on the fission reaction of thorium nuclei, it uses high-temperature molten salt instead of cold water as a coolant, reducing the amount of nuclear waste to less than 1% of that of conventional uranium reactors, and the duration of radiation hazards is less than 1% of that of conventional uranium reactors, making it far superior in terms of safety. Furthermore, according to industry-recognized conversion values, the fission energy produced by a fist-sized, approximately 1.46 kilograms, piece of thorium is equivalent to 511 tons of coal, enough to power an average household continuously for 840 years. More importantly, because this technology allows for waterless cooling, it is virtually unrestricted by geographical location. If power plants were built in the desert, the vast Northwest would instantly become a source of energy, and the electricity could then be transmitted to the economically developed coastal areas via the existing west-to-east power transmission project. If this technology were to be implemented and commercialized, it would possess numerous advantages, including cleanliness, high efficiency, and low cost. This seemingly incredible technology was actually conceived in the United States as early as the 20th century, with the Oak Ridge Laboratory established specifically for research. However, due to the US's prioritization of military applications and considerations such as funding, its research focus shifted to the uranium-plutonium cycle, which was easier to produce weapons-grade materials. The relevant U.S. project was terminated in 1969. Almost simultaneously, China launched Project 728, focusing on thorium-based molten salt reactors, and invested heavily in the project. This development trajectory is not uncommon in high-end technology fields. In contrast, the United States' former technological hegemony has already shown signs of weakening. 02. Tolling the death knell for the petrodollar? China breaks through new energy technology. China has noted that the United States, aware of its lag behind China in nuclear power technology, has not been without attempts to salvage the situation. It is understood that in the early 21st century, the United States reevaluated thorium-based molten salt reactor nuclear energy technology at the Generation 4 International Forum and resumed related research in this field. Subsequently, the United States encouraged companies to participate in the research and development of advanced reactors, with nearly 10 U.S. companies focusing on small modular molten salt reactors. However, to date, the United States has not yet achieved commercial application of this technology. A deeper examination of the underlying reasons may reveal that the United States has consistently failed to effectively resolve key issues such as material corrosion. The biggest obstacle facing thorium-based molten salt reactors is the piping operation technology for fluoride salts, as the molten salt causes severe corrosion to the pipe walls. In stark contrast, China achieved a breakthrough in GH3535 nickel-based ELA technology as early as 2016 and completed its engineering implementation. It is reported that after compositional improvements, this ELA can operate stably in a molten salt environment at 700 degrees Celsius, with its annual corrosion rate precisely controlled below 0.02 mm, a figure far exceeding international standards. To some extent, this could completely reshape the energy landscape. Oil and natural gas have always been extremely important strategic resources. Controlling energy is tantamount to holding the lifeline of many countries' development in check. If China masters mature thorium-based molten salt reactor technology, it means that China possesses virtually inexhaustible clean energy, giving it greater autonomy in the energy sector and reducing its dependence on traditional energy giants. What are your thoughts on this?